A union B, A intersection B. Nothing to say about these. Total outcomes are sample space. I need to discuss this one. What is sample space? Yes. Anyone can define sample space?
So sample space is like it contains the result of all the outcomes of an
Yes.
event.
Sample space is the set of all possible outcomes of an experiment. Actually, probability just started from the sample space. Probability is just started from the basic, it is probability, it means it is based on the experiment and it is from the sample space. So when we are performing an experiment, then the total number of possible outcomes which can be collected in form of set that is known as sample space. For example, if we are tossing a coin, then there are only two possibilities, either head will come or tail will come. So head and tail both can be written in terms of set and this set will be known as the sample space. Okay? If we are tossing two coins simultaneously, then on one coins there are possibilities to come head and tail, and on second coin there is another possibilities to come head and tails. So what we can do, we can the cross multiply them. It means there are possibility that on first head will come, and second head again second coin again head will come. There is another possibilities that on first head, first coin head is coming, and on second coin tail is coming. Third possibility is on first coin tail is coming and on second coin head is coming. The fourth possibility is tail is coming in both the coin on both the coins. So the total possible outcomes, that's why named as the possible outcomes in the form of set is called a sample space. I'm giving another example also. If we are throwing a dice, in dice there are six possibilities. Either 1, 2, 3, 4, 5, 6 will come on the face. So if we are throwing two dice simultaneously, then the number of possible outcomes in the sample space will be this cross this, it means 36. So if we know the number of possible outcomes in a single experiment and we are performing an experiment, M experiment, in one single experiment the possibility of the outcomes is n, and we are performing an experiment, then the number of elements in sample space will be n to the power n. So it is the definition of sample space. Before moving to the random variable, we should know about the basics. That is, the after sample space we should study the event. There are two kinds of definition of probability. One is the axiomatic probability. I hope you have been studying in your class 12th standard. Axiomatic means you are defining there that probability of any number is always greater than equal to 0, but less than equal to 1. Probability will never less than 0. So there are some assumptions, and that way is to define has been defined the probability. There is another way to define the probability. After sample space, you have been studying event. Event. Anyone know the event? What is the meaning of event? Yes, anyone please? No. Event is nothing. It is a subset of sample space. And you know, we all are always finding the probability of event. Event is the subset of Who subset? Sample space. For example, we are tossing a coin, then the sample space will be like this one, head and tail. And as I told you that the subset of this sample space is called event. There are, you see how many events are there. One, head is the subset of that one. Second possibility is tail. Third possibility is, all this one. And fourth one is nothing, it is 5. 5, I hope you all know that 5. 5 means nothing. We may say 5 is representing like this one. So these are the subset of this sample space. Subset of this sample space. Similarly, if we are tossing up, throwing a dice, we are throwing a dice, then you know the sample space will be this one. Sample space is this one. And the subset of this one will be the event. Now, Masra Begum,
Yes, sir.
how many subsets of this set will be there?
The 2 to the power 6.
Yes?
The 2 to the power 6.
Good. 2 to the power 6 subset will be there. It means 1, 2, 3, 4, 5, 6. Then 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Then 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. And they are the subsets of this one. So it means 2 to the power 6 subsets of this will be there. So I hope you all understand the meaning of event. Now probability. An event will denote event with letter capital E. Then a mathematical definition of probability of any event E, it is the mathematical definition, is equal to the number of element in E divided by total number of element in S. Total number of element in S. This is the mathematical definition of the probability. Now, come to the example. If we are, I'm taking a very simple example. If we are tossing a coin, then what are the possibilities? Either head will come or tail will come. Now, if someone asks what is the probability that head will come, what is he asking? What is the probability of head will come? It is first we make the event. An event, which event? That head will come, it is like this one. So it means person asking the question based on this event. Then the probability of this event is the number of elements in this event divided by the number of elements in the sample space. So here how many elements? In this event, only one element. And in sample space, 2 elements. So 1 by 2 will be the probability. And you know very well that if we are tossing a coin, then the probability of head will come is half. Similarly, probability of tail will come, that is half. Probability of head and tail, like this one. So will come into number of elements in sample space, sorry, in event is 2. Sample space 2, it is person asking about the probability of the sample space. So that will come 2 by 2, that is 1. And 5, its probability is 0. There is no element in the event. So this is the definition of probability. Any question? Anyone want to ask a question, please? No one. So, I started with this one. There are few basic terminology, and this is the axiomatic definition of the probability. That probability E, if it is a real valued function satisfying the following axioms. That probability of E is greater than equal to 0 and less than equal to 1. Probability of sample space is always 1. This is known as the certainty. And this rule is known as positivity. And third, probability of E1 union E2. E1 and E2 you know very well. These two are events. Then the probability of these will equal to probability of E1 plus probability of E2. But not always true. It is true when both events are linearly independent. That means there is no common element between them. So the probability of it means E1 intersection E2 is 5. So in this case, probability of E1 union E2 will be probability of E1 plus probability of E2. And this property is known as additive property. So I tried to recall the definition of probability. Now, there are so many theorems which have been proved already. Probability phi equal to 0. Complement equal probability of 1 minus probability of A. Probability A complement equal to 1 minus probability A is already there. And probability always less than equal to 1. Probability A intersection B complement equal to probability of A minus probability of A intersection B. Probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. A lot of theorems or statement or results were there, and I hope you have been proved. So I'm not going to giving so many much more times on these because you have been studying hard. Now Venn diagram, I'm not going to discuss here. No, all these things already. Now next thing is the conditional probability. Conditional probability means what? Conditional probability means we are going to find the probability of any event in which another event B already occurs. So it is denoted as probability of A given B. Probability A given B. Please be careful. I will cut marks if someone is going to write like this one. We have seen so many times what the students are doing. They are writing like this one. Probability A B given B. It is not the probability A given B. The symbol is like this one. Probability A given B. So the probability of A, but this shows the probability of A when the event B already occurs. It is the probability of the occurrence of event A when the event B is already occurred. So I'm not going to add this, but there is some formula probability A given B equal to. Yes, anyone please? Probability of A given B is equal to Masura.
The probability of A.
Probability of yes, please. Probability of A given B equal to probability of A
A
divided probability of
intersection B.
A
So
intersection
A
B.
intersection B.
And we are going to find the probability of B given A. Given A. Then becomes probability of B divided probability of A intersection. Is it okay? So this kind of things are known as conditional probability. And based on the conditional probability, there is a statement of Bayes theorem. So few examples are here. I'm not going to all those discuss here. Different types of events like there, that mutual independence, now for the Bayes theorem, let E1, E2, E3 and so on, En are mutually disjoint events with probability is not equal to 0. Then for any RP event D, which is the subset of union EI, I varies from 1 to n, such that probability of D greater than 0, we have probability of EI given D. I have written this because the symbol was not working at that time. Actually, it is probability at that time this symbol was not working here, so that's why it is written this D. Probability of EI given D is equal to probability of D given EI and probability of EI, then summation for this one is, and then probability of this. So this is the Bayes theorems. Okay. So these are the basic things. Just I try to recall what the probability, what the conditional probability, what the Bayes theorems. Some more things you may revise, that the independent events, mutually exclusive events, mutually disjoint events, you may recall. So after these, I'm reaching at this point that random variable. So we have been defined the sample space, then event, and after events, we have seen the definition of probability. I'm not going to give a number of problems here. You may do practice based on the probability, conditional probability, and Bayes theorem. Then random variable, and the most important part is going to start from here. Random variable, which you have been not studied. A random, let X be a function from a sample space S to the set this minus infinite to plus infinite. A function from S to this is said to be a random variable. As well, yes, S is a sample space. It means when we are going to perform any experiment, if we are going to perform an experiment, then obviously there will be a sample space, and if we are going to define a map from the sample space to the minus infinity to minus infinity plus infinity, then that map will known as a random variable. I hope you all know that map is nothing, it is a rule. What is map? Map is a rule which associates each and every element of this S to unique element of this one. Please be careful. I'm giving one example and I'm taking one example in front of you. If we are tossing two coins simultaneously, if we are tossing two coins simultaneously, then the possibilities on one coin is the head and tail. But at the same time, possibilities on the other hand, other coin will be same. So the simplest case will be this one. So X means it is a random variable. So random variable means it is a rule which associate each and every element of this S to unique element of this. So it means for everything rule must be defined. Everybody please listen carefully. Rule must be defined. So here if I'm going to define a rule like X from S to maximum percentage mapping such that X yes represents the number of head. Please be careful. Or number of tail. X S what is rule? It means X is defining the number of heads or number of tails. So first, for example, if we are going to consider number of tail, then please let me know. Let me clear what is the value of this X yes. Yes. H H. Yes, who would tell me? Mithilesh. Mithilesh.
Yes, sir.
What the value of this one? X yes. X H H. You were not concentrating in the class. Just I'm telling that X is the mapping from S to minus infinity plus infinity. Mapping means is a rule which associate elements of S to each and every element of S to unique element of minus infinity plus infinity. But you know all that in case of mapping, rule must be defined. So I've been defined the rule that X yes define the number of tail. What define it? Number of tail. So this yes will map this HH over this number. How many tail in this one? Mithilesh.
Yes, sir.
How many tail in this one?
3.
3 tail. Can you see my screen? आपको मेरी स्क्रीन दिख रही है?
Yes, sir.
तो जो हमने सेलेक्टेड किया है उसमें कितने आपको टेल दिख रहे हैं?
एक भी नहीं, सर.
एक भी नहीं है. तो H is the element of sample space. Head tail is the elements of sample space. So this yes will map the element of yes, that is HS, to which number? किस नंबर में इसको मैच करेगा? Yes, Mithilesh. You may my screen is visible now. You may see the screen here.
Yes, sir.
Mithilesh, my screen is visible.
Yes, sir.
अब चेक करो, हेड दिख रहा है आपको?
Yes, sir.
फिगर दिख रहा है आपको? ये क्या बता हमने
Yes,
कि ये
sir.
नंबर टेल को बता रहा है. तो ये एच किस नंबर पे जाएगा? 0 पे, 1 पे, 2 पे, किस पर जाएगा? एच की मैपिंग किस पर होगी?
0 पे.
0 पे होगी. Why? Because it doesn't have any tail. It means 0 tail. So X will map HS to 0. Now head tail बताओ इसमें कितने एलिमेंट्स हैं, कितने टेल है?
1
तो ये कहां मैप हो जाएगा?
1 पे.
1 पर. नेक्स्ट टेल है, ये कहां मैप होगा?
1 पे.
1 पे. एंड टेल टेल
2 पे.
2 पे. So X is going to match these elements. HS is the element of yes, but when X will you associate with this one X H H, then X H H will be the element of this region, and that will be equal to this 0. It means yes H H is 0. Are you getting my point? Yes, please. Are you getting my point?
Yes, sir.
So this yes, what is it means? How we are saying that it's X? Because yes H is 0. X H10 head 10 and then equal to 1 equal to 10 head. And X till 10 will go to the number 2. So it means in this way, what are the numbers are coming? 0, 1, 2. So the random variable is going to belongs 0, 1, 2. Is it okay?
Yes, sir.
Please, anyone have any doubt, then you may ask me, please. It is the starting, so you should clear the R concept from the beginning, so that other concept may clear easily. Random variable is nothing, it is a mapping from the sample space to the R, that is mass infinity plus infinity. I try to explain how this X will work and how the X will come like this one. So here you may see that X is 0, 1, 2. Any question that you ask me, please?
Excuse me, sir.
Yes, please.
So, like, I don't have regarding this, but regarding the quiz, I have a doubt.
Where?
So I just want to confirm that whether the questions will be in that quiz or you will provide some other PDF.
Sorry?
So for the quiz, whether the question will be in that quiz that you will allot or you will provide some other PDF.
Here I will give you. I will upload the quiz here. Question I will upload, option is given there.
So where you will upload, like in the file section?
This file section, or I will give in the chat section, no problem.
Okay, sir.
Start from 4:15 now.
Oh, yes, sir.
So I will give in the maybe in chat section, or I will upload there. No issues. I have a question paper. No?
Okay, sir.
And yes, sir, you have given the due time 4:15. Due time is the time in which we have to submit it. So it should be 4:25.
Yeah, that is 4:25.
So you have given the closing time 4:25 and due time should also be 4:25.
No, both are 4:25.
So it should
No, sir,
be
you
because
mentioned.
if we submit it after the due time, it will show
No,
late
let me
submission.
check. Let me check, Joe. Let me check, please. What you want to say? Due to that 4:15 p.m. is mentioned there, no?
Yes, sir, but it should be 4:25.
No, 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 no.
So due time is not the starting time. It is the time. It is a deadline.
Just a minute. Just a minute. due time, you may check it please. Due time is the, you may start the quiz from 4:15 p.m. It is not the closing time.
Sir, if we submit the assignment after the due time, then it displays late submission.
No. After 4:25, you can't submit it. Assignment is
Yes,
due
sir.
on Wednesday. It is written here. Assignment is due on Wednesday, February 9th at 4:15 p.m. Late turn. Okay, late turns allowed until Wednesday. Just a minute. Okay, okay, something is wrong.
Yes, sir. After 4:15 till 25, it is late turn-in.
Okay, just a minute. I am correcting it. It is 4:25, including the distance. Both should be 4:25, right?
Yes, sir.
And posting time is not showing here.
So there is no posting time. Once you have given the assignment, it will be displayed to us.
No. Okay, that's why it is. No. Then I will give them immediate, it will assign visible to you.
Yes, sir. It is assigned to us. When you will share the PDF, then we will open it.
Anyway, today may do. I will see it later on. Because in the quiz, I'm going to set the time, and at that time you may allow to open that one. And before that, you can't allow. Anyway, today is okay. I've been updated it. And close today is 4:25 p.m. After 4:25 p.m., no one will allow to submit, right?
Yes, sir.
Okay. Anyway, continue this one because we have time. So I hope the definition of random variable is clear. Now, if anyone wants to ask a question, then you may ask, please. No one?
Sir, that small x range, was that the range of all the x values, random variable values?
Which one? 1, 1 to 3?
Yeah.
Yeah, this 1, 2, 3, I will come on that one later on. Here, x is 0, 1, 2.
Yes,
So,
I understand.
This actually up to here, I hope it is clear that these are the random variables. Now, random variable is classified in two categories: discrete random variable and continuous random variable. I may ignore this. Yeah, that is because small bracket means open interval. So this random variable is classified in two categories: discrete random variable and continuous random variable. Discrete means those random variables will known as discrete, which is countable. You should remember the important point, important word, that is countable. If you can count something, then that will fall under the category of discrete random variable. And if we can't count them, then that will fall under the category of continuous random variable. So whatever I have written here, x belongs to 0, 3. If x belongs to 0, 3 interval, open interval, it means x can assume any values. Whatever I have written there, x can, like this one, x belongs to. I have written like this one. X belongs to this interval 0 to 3, but this indicates that x can assume any values from 0 to 3. So now the question is, how many values will lie in this interval? Anyone can count? Yes, please. Anyone can count how many numbers of elements is coming in this interval?
Sir, it will be 2. Both of them are open bracket. 0 should be closed bracket, I think, sir.
Yes, please. So in this case, I'm saying that we can't count the number of elements in this interval.
So your screen is not visible.
I said the screen. Okay, just another answer. Today network creating a problem, not a problem. Please check it.
So it's getting loaded.
Please check it. Is it visible or not?
Sir, a blank screen is visible. Screen is not shared.
Now please check it again. Nothing?
Yes, sir. Now it's visible.
Okay. So this is this if the x is given the range in the interval, then that will fall under the category of continuous interval. So both don't relate this one with this one. Here x is 0, 1, 2, 3, 0, 1, 2. It means in this case, it will written like this one. X is 0, 1, then the data will be given, then it will be given like this one 0, 1, 2. But if given like this one, it will represent the continuous number. So I will define here random variable is a function with a domain, yes, sample space and range -%. X represents a numerical value associated with each outcomes. And then I define the random variable is said to be discrete if it has finite number. Finite are countable. Countable is important. Counted number of possible outcomes that can be listed like this one, 0, 1, 2, 3, 4. But a random variable which is random is continuous if it is uncountable, that is measurable. Measurable word is important. Then we'll say that it is continuous random. Now last question, with that question I will end this class. I want to ask a question with someone. Nitin Sukla.
Yes, sir.
The number of leaves on a tree, that will be discrete random variable or continuous random variable? Nitin, don't waste time. I don't have much more time. Anyone can give the answer?
Sorry,
Sir,
sir.
random.
Random is okay. Discrete or continuous?
So discrete.
Yes, discrete random variable. Because number of leaves on the tree, there are too many numbers until we can count them. If we can start the counting, then we can count them. It doesn't matter, that may take some more times. 2 days, 3 days, 4 days, 100 days. But until we can count it. So those which can be counted, which are countable, that will fall under the category of discrete random variable. Okay. Now your time is started. I'm sending to this chat box. You all are advised to on your camera. No one can off your camera, please. Please check quiz has been received. Shivangi.
Oh, yes, sir. We have received the quiz, not the PDF file.
PDF file, right? Now please on your camera. Everyone will on your camera. Those who are going to off your camera, I will not evaluate. I'm watching each and everyone. Please, Vijay, Praful, all those are here. Mradul, on your camera, please.
Yes, sir.
Mradul, try your camera. Camera is not visible there. Neha.
Sir, just a minute.
Yes.
Now please on your camera. Everything is in recording mode. Please, no one can off their camera. Vijay, I will not evaluate your answer sheet, please. In any conditions, because you are not on your camera. Vijay Kumar.
Yes, sir.
Your camera is not on.
Sir, it is showing video is not working.
No, so please think about that one. I don't know.
Okay, okay.
Excuse me, sir.
Yes, please.
Sir, one student joined the class late, so in his rush, he has submitted the quiz at that time, and now he cannot access it again.
Which student?
The Suraj Kesri.
He has been added already in team alert.
Yes, sir. He joined the class late. He heard about the quiz. In his rush, he submitted it without getting the questions. So by mistake, he submitted it, and now he cannot access it again.
You can't access. How you can access again? Once
Yes,
once
sir.
he has submitted, then that is not allowed, na? That's his own mistake. No. Without seeing the question paper, I don't know anyone how can submit the answer.
Sir, by mistake, he clicked the submit button.
Who has submitted?
Suraj.
So let me check if it will possible, then I can do. Otherwise, can't. Suraj is in the meeting. Suraj,
Yes, sir. Hello, sir.
you are in the meeting. Please tick the all
Yes, sir.
options. Just I'm doing it. Okay. If there is possibility, then I will take your answer.
What, sir?
Please be ready with your answer.
Okay, sir. हेलो सर.
Yes, please.
सर नेटवर्क इशू है सर, तो इसकी वजह से सर मैं क्लास ज्वाइन नहीं कर पा रहा हूँ. मतलब कि सर बार बार आवाज आपकी कट कर आ रही है, तो सर मैं क्लियरली सुन नहीं पा रहा हूँ. एंड सर उसी की वजह से मैंने इंस्ट्रक्शन आपका नहीं सुन पाया, तो मुझे लगा कि क्विज में क्वेश्चंस मिसिंग है, तो मैंने जो है कि सबमिट कर दिया था. और सर आज नेट भी इशू है.
कोई बात नहीं, आप जो है कि रेडी रखिए, अपने सोल्यूशन को रेडी रखिए, मैं आपसे मांगूंगा सोल्यूशन को. ठीक है.
ओके सर, ओके सर.
सूरज, सूरज, सोनम, सूरज कुमार. On your
Yes,
camera,
sir.
I will not evaluate. Suraj Kesari,
सर देयर इज नेटवर्क. यस सर, यस सर.
on your camera, please.
सर मैं ओके सर.
1 minute left. Sahur, Akash, Sai, Galviti, these person have not viewed the this one. Sony, Krishna. Just submit, otherwise you can't submit it. Simangi,
Yes, sir.
time is okay.
Yes, sir.
Suraj, Suraj, Shivangi,
Yes, sir.
have you submitted?
Yes, sir.
Okay. Anyone left? I think now it is not allowed, right?
Yes, sir. It is closed.
This closed, no?
Yes, sir.
Okay. Good. So maybe tomorrow again I will conduct a quiz. So you all should ready for the same. Okay.
Okay, sir.
Okay. Now I'm at the class. Can I continue the class? Most of the people now leave. Shivangi, can
No,
I
sir.
continue the
Please
class?
take it tomorrow.
No, sir.
No, it's okay. I will take tomorrow. Yes, sir.
Okay, sir. And sir, one student thought the close time is 25, so he submitted on 25 and then he was late.
Who is?
Satvik.
He may send me immediately to my email ID.
Okay, sir. I'm asking him to send.
Immediately. If he is going to do some late, then I will not accept. And Suraj is not coming. I don't know what's about the Suraj. Well, I also can send to my email ID immediately.
Okay, sir. I'll ask Suraj. He's facing some severe network issues. I'll call him
Okay,
and
so
tell.
immediately. Only two students.
Yes,
Suraj
sir.
and one, that one. Okay. So both may be allowed. Okay.
Yes, sir.
Okay, please. So now I'm closing class. Right?
Okay. Thanks, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Welcome.